Welcome, everyone. Thanks for joining. We have an interesting topic today, mastering Altium Harness Design, tips, techniques, and real-world applications. Before we start, we should turn off our cameras, turn off the sound so we can clearly hear the speaker. We can write all your questions, you can write in the chat. We will discuss these questions, these technical queries at the end of the webinar. And Sheria will navigate you through those answers. And we have also a survey in the chat. We have a live chat, and you can leave your vote. We have raised the question regarding your past experience with the tool, with the software, and it's helpful for us to understand our attendees a bit more, backgrounds of yours and your previous experiences with the tool. And I would like to start with a brief introduction of WiredWhite platform, what we do and why we do it and what is it about. So WiredWhite is an engineering platform. It's a sort of a network for, let's say, less experienced engineers like students and more experienced engineers like young professionals or midterm professionals, experienced engineers that we bring all together on one platform. And we see our role as a sort of technology and engineering knowledge exchange enabler by bringing them together on our platform and providing them useful tools for collaboration, for team interaction, and for project processing. And why we do it? Because we see ourselves as a contributor into the electrification worldwide. We try to accelerate the process, optimize the process, and to help, let's say, electrify all the applications that would be possible to electrify. And we believe that it is our mission, and we believe that it is possible through the enablement of such a platform and enablement of the global cooperation and knowledge sharing between engineers and students, engineering students. And I would like to introduce our speaker today is Sheria Khan. Sheria Khan is electromechanical installation design engineer with 5 years of experience in automotive systems. He's specializing in the design and integration of autonomous vehicle components, including compute boxes, ADAS systems, cameras, ECUs, and wiring harnesses. He has previously worked at Volkswagen Group, gaining hands-on experience in ADAS, camera integration, sensor design, and vehicle packaging. And his experience spans 3D CAD design, SolidWorks, Altium, and 3D printed enclosures and wiring harness layouts. And Sheria holds a master's degree in mechanical engineering. He has filed patents in mechanical design in China, reflecting his innovative approach to vehicle systems. He is fluent in Chinese, and he collaborates effectively with global suppliers and partners in that manner. And beyond engineering, obviously, he is also passionate about knowledge sharing, having created courses on wiring harnesses and manufacturing support, already to support learning process, to support the best practices exchanges and electrical mechanical integration. So welcome, Sheria. I'm happy to have you as a speaker today. And you can move on with the topic.
Thank you. Yeah, so I'll just start sharing my screen with you guys so that we can have a first look at what we gonna do in this live webinar regarding the Altium schematics, harnesses, and also the layout. So I'll share my screen, and then we can I'll take you through the PPTs slides, what we have. So basically, the main subject or topic for the harness creation is for a battery pack. And this is a battery pack with a 3D design, and it is not having any harness, and it's also having a battery management controller. So for such kind of 3D model or system concept to design a harness, first of all, we have to think about the connectors, what kind of connectors are going to be connected, and also we should know the pins, which pins are going to be used and how many pins are going to be used for such kind of battery management system and battery pack. So the second thing after locating our connectors would be to think about the layout of the battery management system harness. So for this reason, we have to be, before designing or before going to Altium, we should have some ideas in our mind, like what could our harness look like. So for that, we will draw a rough sketch on any image or picture, whatever feasibility you have. So the battery management control system controls the battery battery signals and all these things, and for that reason we have a connector which will be connected to all the ports in this battery pack. So we have a JST XH connector for that, and it's having like 16 pins, which will take, each pin will take the current to the battery pack, to the batteries inside the battery pack. And we will have the positive and negative terminals connected of the battery, and also we have Anderson Amphenol connector, which is a power connector, and that will be connected back to our main power source. This is the current organization of this harness layout, and then once we are done with this, we should know that what kind of bend radius is our harness, bundle diameters, and these things. We can specify that in Altium Harness Design. And this is how our schematics looks like. And I will take you through the schematic first. And I believe that let's start doing it on Altium as a project. So this is the one which I created a while ago, and I'll start a new project and keep that one as in my macros. So to start a project on Altium, this will be your main project window where you can save your projects in your local computer, and also your a server on cloud server where you can upload your projects, and then easily anyone can see it. So, and also we have version controls, and local projects, which I just described, will be saved into your local folder. And for now, I'm just saving it on my webinar document. And I'll just, yeah, this is the folder which I'll select, and then I'll choose harness from here, which, okay, this is where we should be saving our folder. The previous one was for my PCB project. And I'll select this folder, and I'll just name it as battery pack harness 1. And parameters, well, we don't need to take care about these things. Altium manages it by itself. So from here on, we will create our project, and this is your project tree, and everything about your project will appear here. So I'll click this project and start adding the wiring schematics diagram, the sheet, first of all, because we are working in a 2D, so the sheet will be added. And this is your schematic sheet. And then we will have our layout drawing sheet. And after that, we will also add BOM, which is an active live BOM provided by Altium from different sources where it collects data from. It's online and it can give you a lot of access to the connectors, to your pins, terminals, wire gates, each and everything relevant to your harness. And once this is created, sorry, it'll just take a bit of time. Yeah, this is your BOM sheet. And then we will be adding our draftsman document, which is also relevant to our manufacturing drawing, where a manufacturer can see this drawing and then he can make this harness for us. So I'll go back from the tree to my wiring diagram. First of all, as we can see that this sheet is a bit smaller. So the first thing we will have on the right side, we can activate all these component properties, store manager and messages from this panel. And I have already activated it. So I'll just directly go to my sheet properties. From here on, you will see the sheet properties. So in general, you will have all your sheet properties at the beginning, if I want it in mils, or I want my sheet, the units could be in millimeters. So it's up to you. And normally what I choose is I would select the smallest number for this purpose. And the reason behind it is that I want my cursor to be moving, or the snap grid to be moving in less than 0. So I can easily draw my drawings on the sheet. And after that, we are good to go forward, but I would like to also extend the sheet size or the page size. And because my harness will be a bit longer or bigger, you can say. So I'll choose a standard template here for now. We have different page sizes where we have A1, A2, A3, A4, and so on. And you can create even your own sheet in here from your libraries, and that's also possible. So for the current project, I'll just take A3, and yeah, it's the sheet size or the page size changes automatically. Right, so here's our sheet size. Now, the second thing which we should be doing is we should be going to our components right here at the top. And from the components, we should be able to find our connectors, which are required for our project. So first of all, the first connector, which is the BMS controller connector, it's basically a 16-way HP 16-way XH connector. I've already downloaded this data sheet, which you can look here. It's a HH connector, and the terminals or the crimps which are going to be used in this connector for the conductor inside. For every wire or a conductor, normally there is a crimp, or we call it a terminal as well, which is going to be inserted in each hole of the connector. And they are normally tin plated, aluminum, phosphorus, bronze, and different categories, but gold as well sometimes, but it depends on what type of conductor you're choosing as well. And your wire gauge is also important here. AWG is the American wiring gauge standard. And the wiring gauge depends upon the numbers, and normally we use it like from 10 to 30 is what the normal wire gauge looks like, or the cable gauge. So as your number increases, let's suppose from 10 to 11 to 12 to 13, your wire size will decrease. But if your gauge is increasing, your wire size will also decrease. That's something about the American wire gauge system. So the more the wire gauge, the smaller is your diameter of the cable or the wire. And once we are done with all this, by selecting our connector and also our requirements for the Phoenix connector also, I'll just show you a lug which is going to be connected on top of the batteries. Here on top of the battery terminals, we are using lugs, and their size is also mentioned from Phoenix Contact. It's M8 size, and this is your wire gauge size, and of course this is a ring cable lugs, and the color is red. Normally connectors and wires are color coded to be identified easily, and that's what these terms represent. M8 is the size of the ring, which is 8 millimeters, approximately 8 millimeters, and this is what we are going to be used. So the first thing in Altium is you should be able to find your lug, and the number for that lug, which is written here. This number is important. This is the manufacturer part number. You will copy this, Control C, and then we'll move on to our component search library. So here, if I enter this number, it will directly give me the connector, which I have already saved in my library. If I right click, or if it's not appearing here, you can click manufacturer part search. It'll take some time and it will search your part. Here we go. So this is already stored in Altium's library, not in my own cloud server. I'll save this into my library, cloud server, my own. And as I have already saved it, so I'll not save it again. I'll just take this, and what we can do is edit this. Every time you would like to save a connector to your own library, you will have to edit it. And if there's a chance that there is a 3D model inside the properties of the connector, then you don't need to add these symbols and these 3D connectors or footprints here. If they are not present, then we can definitely edit from this tab here. And as it's already added, so I can remove it and add a new symbol here. Since I have already done it, I think there's no need. It's very easy. You just edit this, press edit. You can always create it, or you can edit directly from this pins tabs as well. Next step would be adding my 3D connector. If it's not added, I will go and press this edit, and it will take me to the connector's 3D model, which we can rotate and have a look at it, and also define the coordinates, XYZ coordinates of my connector. When the reason for that is when I'll be importing it to 3D part model in SolidWorks or CATIA or NX, I must have some coordinates. So the Z, you can see here, normally Z is what the Z coordinate is, what the direction of your pin will be or your harness will be. And for this instance, this is how it looks like. So this lug is having a ring here and a terminal which will be pressed by a crimping tool so that the conductor or wire will be inserted in this. That's the only reason that we are creating our harness in the Z direction. And to define the properties, you would just double click your part and it will take you to the properties of this part. And normally I would choose this. Yeah, here you can play with your coordinates, rotation along X, Y, and Z direction. And also, if you want to move it upwards and left and right in X, Y, Z coordinates, you can also do that. Once this is done, you'll go back to your connector and just simply right-click, save or save to server. If you have a cloud or membership of Altium Harness, you will definitely save it to server. And you'll release it and press OK. That's how it's done for all the connectors. Now the next step is to bring in the connector or the lug into my sheet. You'll just drag it from the components, just hold it, drag it. So since we need around 16 connectors, 16 lugs for this project, I'll not be doing all the 16 of them. I'll just create 8 of them and then show you how to create a manufacturing drawing. So I'll be quick and I'll be silent for a while, or I'll be, yeah, let's take this and just copy, Control C, Control V, keep pasting it until you finish the quantity you want in your drawing. And also here, I'll start pasting it. And the reason for me doing it vertically is because I'm trying to align with the layout which I created here, if you can see. And this is what I want to follow. So my harness will, by the end, it will look something like that. Yeah, this is how it should look like. And now the next step is to bring in my main connector, which is the XH connector 16-way. I have already saved it, so you can save your harnesses or your save your connector, sorry, into the library the way I showed you. Just right-click, edit, and then you can play around with your connector properties as well. I'll just hold it and then bring it in. Now, the direction of my connector is in the pin's direction is on the left side. So I would like to just rotate this and bring it to the right side. For this reason, I'll just press spacebar, and there you go. So it rotated around 180 degrees. And this can be done easily by pressing the spacebar in your keyboard. And we can do similarly for other connectors. Let's select them all. Select all, and then you can move them a bit upwards so that we get more space here. Now this one is correct, direction of the pin, and I want this lug to be on that side, so I'll just rotate one by one. And this one. Now you can see all the connectors are in your schematic, and your main connector is here. Now the next step would be to create our schematic. So your schematics actually your schematic doesn't literally depend upon your layout. You just need to create it in any direction you want. So I just said that I'm creating the layout, but it's a schematic. The layout is the next step, which is going to be done here. So I can just put my connector here and then take it back here. And I'll just leave them, these ones here and these ones up here. I actually need 8 of them. I might have brought in many. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's correct. Let's turn them around. Click spacebar. They will rotate quickly. You can do this And the other way to do that is, if we want to rotate it, you can use the properties tab from here. Just double click your connector, the properties tab will appear, and then you can start rotating it here from your properties tab here. You can click this rotation and then it will start rotating in any direction you want. Next, since this is my main connector, which is going to be connected into the battery management controller, the next step is to create my pin connections. For that, this tab is always on in Altium Harness Design. So I'll place my harness wire in this. So I'll click that and it will bring in to me, it will bring me into the sheet, and then I can just play around with whatever shape I would like to create for my wires. So for current project. And the other thing you can do is, once I'm dragging it, you can just give it some different directions to your wire. This is the 45 degrees. It's following the 45 degree from where I started my wire into the lug. So I'll just take this 45 degrees, and this can be done by pressing Shift and Spacebar together. So you can click it. This is any angle. I can play around with it, and then I can set it up in any direction. And the third is a 90 degrees. If I double click it, it will give me a 90 degree direction for my wire. And so since I want a 45 degree, so I'll just Shift Spacebar and then zoom in, connect it to my pin 1 on the main connector from the battery management controller. So we should know all the properties of our pins as well, like what is going into which pin is going into which connector. And this red dot means that it is connected to my pin from A to B, from one here to one here. This means that my wire is connected. I'll be doing it quickly for the rest of them. Zoom in, and then actually, you can start your wire from any direction. I mean, you can start from main connector or in the connector in which it will be terminated, so it doesn't matter from whichever side you start. Seven. So now here, this is another good thing which we have found out here. This means that my wire is not connected to the connector, this square. And this happened because I couldn't align it properly with the connector, the pin of the connector. So what I'll do, I'll just move it back a bit. I'll move my connector upwards a bit and then drag it back into this pin white area. That's how it's going to be connected, and then we'll keep marching on. I want to do it as quick as possible, but Altium takes a bit of time and patience to do because it's wiring and everything should be connected properly. Otherwise, you will get short circuits in your harness. And that's the 8th one. Yeah, so these are the 8 terminals and connectors which are already connected into this connector. We can use other pins as well. But since the time is very short for this webinar, I'll not be creating each and everything. Next, since we are done with this, the schematics, next step is moving to your layout. Again, this is the page settings, as I just mentioned earlier. I'll go to my properties, change my units. My snap grid should be 0.254 millimeters. This should be 0.254, 0.254 millimeters. And then I'll just drag this a bit so I can see my page layout. I want to choose A3 again. And this is very important, choosing your layout. Sometimes we have to create form boards. So this layout, the page layout, depends on forming your board as well. So the size of, and you can also customize your page layout. You can just press custom and then you can set up your margins for your page layout. Since I'm not doing that, it's a general harness, general, I would say, lengths. So it doesn't matter what page or whether it can be custom or standard. I choose standard A3 size. Now, you'll be wondering like from where to bring my schematics into this page. Altium has created a tools option and design option, place project in this top these top tabs. You can just bring in your harness into this page. Go to design, import wiring. If you click this, all your schematics will appear here, but without the schematic wires in it. Now this is the time for my layout creation, which is something like this. From here I'm coming out and then my layout will be created. It doesn't matter what the schematics were, how my schematics were laid out onto this page. I will bring this connector here and rotate it 180 degrees again. And then I'll move all these connectors to this side. And then this is what it looks like from the layout, coming out here and then connecting all these 8 terminals of the battery pack. For this reason, I have created a layout in such shape. I'll just bring them back to this side. Definitely you can do this in your schematics as well, but instead of wasting time on doing this in the schematics, we can do it here. So like 1, 2, 3, 4, 5 here, and actually 4 on each side. Also, another important thing which I forgot to mention is that we should be naming our connectors. Since I have not named any of them, I'll just go back to my schematics and start giving it a designator name for each connector. So, and I have to validate this schematic as well. I'll show you how to do it. In the schematics, first of all, this is our main connector. Here you can choose your designator name. At the moment it's coming out of the battery. So BMS, battery management system main. That's what we will call a main connector. And this comment is from manufacturer's part name. So we'll not change this. If you want to change, you can change it always. But in the designators, I'll choose the main. And then from this lug, we will start naming it as lug 1. Copy lug 2. So we have to do this one by one for each lug. lug 3, log 4, paste it, log 5, log 6, copy paste, log 7, copy paste, log 8. And these are my connector properties, description, like what, and this is all coming from your manufacturer part. Altium is doing it for you by itself. This is a good thing about Altium, and it can show you the data sheet of that connector as well. So from where it's coming, if you just click it, it will take you to the website from where it's been taken. And next is wires. So you should name your wires and give the properties to your wires. Like first of all, I should be designating it. This is wire 1, W1 in designator, and in your comments. You should fill these because once you're validating your project, errors will appear in your schematic. So I'll just hide my comment, but I'll leave the designator, which is coming up here on the wire. Similarly, for all the wires, we should be doing it quickly. W2. W4. Copy paste, you can do Control C, Control V, and be a bit quicker. And then W5, copy, paste, hide. Paste. Hide. W7, W7, and W wire. W, by W I mean wire. So I'm just naming it from W's. You can choose any alphabet for it if you want. So it depends upon you. Hide it. W4. I just forgot to hide this comment. Now the next step would be to define the properties of your wire, which will appear in your BOM. That's important for your manufacturer. Gauge for these cables. I have already checked, and for this lug, we can check again from our properties of the connector. So it's a 10 millimeter square cross-sectional area of the cable. Now we will go here to find out the gauge size. We have a gauge sheet or gauge table. I'll just quickly show you for this one. 10 millimeter square. 10.5 is there, so it's a gauge 7, 6 or 7 is fine. We'll keep it in between that. So 10.5 millimeter square is 3.66 millimeters. That's the diameter in millimeters. And I will just input these values in for my cables, or you can say for my wires. Actually, no, this should be for my cables, as these are cables. These are not wires. I can define the gauge for wire and also for my cables as well. It totally depends upon me. So the gauge for wire, I would take 18, which is with a thickness of around 1 mm. And that's how it should look like. This is the minimum you can provide to your manufacturer. Bending radius, minimum bending radius can be calculated by your bundle diameter and all these things, and also the cable diameter. It's something which needs a bit of calculation, and then you can also input that value here, and then you can describe the name of your wire or cable. So it depends again what is the name of your wire. I will choose the name of the wire of the manufacturer. It's a Belden. Let's take Belden. It's one of the famous companies for manufacturing cables and wires. Next, we will do similarly for all of them. We can also choose the color of our wire, since it's not important for this, for our project, so we'll just leave it. 18 and thickness is 1 mm. Wire 3, 18, thickness is 1 mm. Wire 4, 18, 1 mm. Wire 5, okay, same. And the last one here, sorry, second last, 1 mm. And here is the last one, gauge of 18, thickness of the wire is 1 millimeter. Since this is done, I would put some cables on my schematics, which means the harness cable, you can place it from here, just click it and bring it in, and then just drag it over your wires. How many, if you want 2 wires in one cable, you can just drag it as many wires you want to accommodate in the cable. Since I have many wires, so I'll just put 1 on each. Just drag it and define the size on your page. And this is the last one. Now we have to again choose our cables, name it C1, and this is, and the gauge is, we have just saw it's 7 millimeter, and thickness of that was 3.66 millimeters. This, we have to do this for all our cables. Designator C2. Comment, depends upon you if you want to give or just leave it as it is, and you can hide it. And then again, gauge for this one would be 7. Thickness is 1 millimeter. Sorry, 3.66. Gauge is 7. Thickness 3.66. 7. 3.66. 7 and 3.66. Another one, 7 and 3.66. Second last gauge, that's my thickness of the cable. We would do this for all of them. Once this is done, this was C8 height. I'm defining my designators for the cables. C7, hide your comment. C6, hide your comment. Double click this cable. C5, hide your comment. C6, 4 height C3 height. Now everything is defined, and we are good to go and validate our project, which is here. It's saying that there are duplicate designators. So I have duplicated something, and if I double click this, it will take me to the designator. Okay, so this is basically on my layout, not in the schematics. This error, I'll again check. Yeah, this is because I have already imported my wiring harness. That's why it's coming as a duplicated. So it doesn't matter. We will just fix now our wiring, our layout. This will be a bit quicker. We'll go here and we can see the physical model here in this tab, and then choose which side or what orientation we want for our connector. We have to do it for all of them. Physical model, and then physical view, top, back, start coming up. 0.5 is the zoom in. On this sheet, it defines the aspect ratio, and then next is this one, physical view, 0.5. You can choose any zoom in ratio or any orientation of your connector. It depends upon you. You can just change it from these tabs. Next is this one here, 2D and 3. Okay, top, back. Here. That's it for this side, and similarly for this one here, physical model. We cannot do it all together because every lug or connector has its own designator. They are with different naming, so Altium is picking each connector as its own and giving it each connector its own properties. So and 0.5, this is another one. Here 0.5, top, back. Last one, physical. Click here, top, back, and zoom in as 0.5. Now this one is left, which is the main connector. We can also take its physical view, which is something like this in 2D. And also I would like to take its orientation to the right and left. Okay, since this is on the other side, I'll just leave it as 1. I can rotate it myself. This is the direction. And this is your connection point for your layout, which you can adjust according to your needs. Just click it here. And CP means connection point. I'll hide these CP points normally because I know my CP points for each connector. Rotate back. Select the CP point and drag it and align it straight at 90 degrees. Next one is here. Let's choose this, bring it in. select and just bring it closer, select and just drag it, and then you'll be able to move it to any position you want it to be. So we are doing all this to get the shape of the harness, which we just defined in our layout, and it can always change. It depends upon your requirements. Yeah, then we'll choose, double click connection point, height, CP, height, CP, height. I think these question marks are appearing because I have not updated my harness, wiring harness. I'll have to update it. My schematic, sorry. This one is done. This is done. I think no. Right, so I'll just click design, import wiring. So it's updating my wiring again, depending on the cables I added. Okay, it's taking a bit of time. Yeah, it's all done. And the designators have appeared. Now the next step would be, this is here, and there's a CP point which I can see. I just want to get rid of it. Yeah, it's this one. You can hide it. Now the next step would be to create my harness bundle layout. I'm starting from here. So we have to be careful with selecting our position. This must be red every time to pull out the harness and to pull out your layout out of it, or any pins or whatever you're pulling out. Since there are many wires coming out of it, I'll just create a connection point at this position first. This is the tab for connection point. I can click this, bring in a connection point. So it means that my harness will take this into this position, and this is your what you call around 50-40 millimeters from every connector. This much area should be left for the wires to come out properly out of the connector. Next, we'll keep moving on and start creating our harness in different layouts. So this is going here in here, and then I'll keep it straight, and I'm doing it for the sake of manufacturer, so you can make the harness nice and clean. And bring it here. I'll put in a connection point again here for another connection. For these two connectors, I have already created a connection point. I'll create another connection point for these two lugs. We can call these connection points branches, since branches are coming out of the bundle. Now I'll just connect them quickly since we are running out of time. This one is not connected properly. I'll drag it, connected properly. Next is this top here, and then from here again to this point. Now the next thing is to give connections, or the harness layout will follow this path and get connected here. Similarly on this side. Connect, connect, here, here, again, connect, here, and here. Since this is not correct, I feel it. Yeah, it should match this white point and here as well. There we go. And the last two will be created on each side. Okay, now I have to change the direction to 45 degrees, any angle, and start creating my lines again. Yeah, that's correct. No. So the trickiest part is choosing the right point on your connection point. Otherwise, your connection will not be made to your connector. Then this one here is going to be connected to this connector. Last bit here to here and there. So we're just trying to get some shape which should look something like this, from coming out of here and then branching out to the terminals of the battery. Similarly, from this branch we can extend it to the next section of the harness, but since we're running out of time, which means I'll just stay with what we have designed here. From this connection point, we can create another branch, and then again, in the left and right direction, populate our lugs, connectors, and then start populating your harness or your lines in there. Another thing, if I go and check validate my harness, it will give me some errors, and that's the harness bundle errors. I have to name these bundles. Again, that's another thing. BU bundle 1. Hide this. And this is bundle 2, so that we don't get any errors. That's my... I'll take maybe 5 extra minutes, 5 to 10 extra minutes, if it's okay, Dimitri.
Yeah, that's fine.
Yeah, no worries. Thank you.
Let's finish that.
Yep. And the next one is BU4. This one is here. BU5. BU6. And this one is done. BU7. BU8. 10. BU11. BU12. Let's double check everything is fine. Yeah, that's 10. That's 8. So this connection is not made properly. And how I figure it out, if I double click this, the bundle objects are not appearing here. I should be able to see my bundle objects, which means the wires and cables should appear here with their designators. I'll just try to fix this. This is becoming a one bundle. I'll just delete all my CP point and parameter of my bundle. Let's draw it again from here to here, and this one is correct. Here to here to this one. Let's give them, yeah, now my wires are appearing here and I can see it and verify it that there's something in this bundle. I'll just randomly name this as BU20, but it doesn't matter, whatever name you give it should follow some naming. BU22. Yeah, this one is correct. Everything is in there. Yeah, this is fine. That's fine. And this bundle is carrying all of them. 6, 7, 8. All the 8 cable bundles are in this, from this connection point to this connection point, and it should be in here as well. This is the verification of our schematics, and also you can define the length for each bundle once it's routed. And the routing can be done in SolidWorks, NX, anywhere, and you can now at this point, if you have made your layout, you should be again going to validate it, harness layout connection point. This is duplicated again. So this connection point is CP point. I'll hide it. CP3. I'm fixing another error, which should be quick. And this is for CP2, or CP2 for lug 2. And here is lug 1. Sorry. This connection point is for lug 8. This one is for lug 7. They are hidden, but still we have to fix our errors, so that's very important. And this is lug 6, so that we would be able to not get any errors in our harness and it can be validated properly. Right, I think it should be fine now. Yeah, that's, if there's no messages appearing, it means our harness is validated and there is no error in this. And we can also, if my length is not calculated, let's suppose if I check this, I can manually write my length in here. Since it's not been routed properly, I mean, in any 3D CAD software, this can be done here as well. So length, you can just put 10 mm for this bundle. Yeah, and 10 is appearing here. So we can do similarly for all of the bundles here. Next is we can have a look at our BOM as well. Everything is in there. We can see our connectors, cables, and everything is appearing here. And there's a big list which will be updated here. So you can refresh it and then it will give you the live data, whether they are in the stock or not, volume, production, every information relevant to your connectors and cables can be found out here. The last step here is, again, my document, manufacturing drawing document. I'll be quick with this one. I'll go to my page option, again select A2 this time, since I have to bring in my schematics, my layout, boom, and each and everything in here on this drawing. For that, we'll have to place, first of all, the drawing view, which was this, the schematics. Just place it in here and drag it somewhere else, wherever you want it to be. You can make it smaller as well, since this is the layout drawing, and you can make it bigger as well. So I'll choose this size and just drag it up here. Next, place layout drawing, which is our bundle harness drawing. You can bring it in here, pull, push, whatever you want, just drag it on this page, it'll appear here. Next is our billing of materials, what materials are being used for this harness to create this harness. And the final thing is, the wiring list is another thing which should appear for the manufacturer. He can find out which wire is going from which pin to which connector, and also the length as well. He can find it out from here once it's defined. And the final thing is the connection table. This is the connection table for the whole harness. That's very important. So the manufacturer will look at this connection table as well. And also the connection table for each connector can also be created. So it depends again, what do you want. Double click this in this right tab, components, and select your lug, which means, by lug I mean the connector 5. I'll just pull this here closer to 5, so that if someone is looking at it, he can directly find out the connector information here. And for this table, we can specify what specifications we want in this table. Of course, color is important, color name is important, type of the crimp is important, what terminals are being used, and then part, to which part it's going here. It should be available part number, pin number, length, and the gauge size of the wire. They all appear in this table. So once I would make them visible, they will appear. That's it. And we will drag it. I'm just showing you one so that we don't need to do it for all of them. And the next step would be for this main connector. I'll bring in a connection table closer to it. Since there are 8 connections in it, I can specify or define the table properties here as well, like font, name of the table, where I want to put it on the sheet. Each and everything can be fixed here. And then the main connector, since it was having 8 connections, so all of the connections are in here. I'll double click this and choose what I want to show to my manufacturer who will be making this harness for me. 2-part, 2-pin, crimp details, and also the length should be in there. Yeah, it's already in there. So that's what a manufacturer needs from a harness designer, and he should be able to see all this. And these colors can be defined by you, whatever color. If it's a power or current, it should be red. If it's ground, it should be black. And then similarly, earthing and others should be white or gray. And it depends on your standards and characteristics you want to apply to your harness. By having this much data, your manufacturer should be able to manufacture your harness. And the other step which I wanted to show you guys, if I want to get the length from a CAD software, I should be on this layout page able to go to my panels, and there is an MCAD co-designer in Altium. You can just click it, make your project available online. I'll save my project first in this folder. It's asking me to save it. I'll do that quickly. This is an extra or bonus step I'm showing to you guys, so it'll be quick. Since I'm using SolidWorks, so this harness should be visible in SolidWorks. Yeah, I'll push this layout to MCAD co-designer, and then I'll make it visible in SolidWorks. Close. Share with the mechanical engineer, so I'll give the information here, and he would be able to see this. I'll push this to MCAD and first push, send. So my details are already there with the MCAD, MCAD and ECAD plugin in SolidWorks. So I'll be directly showing you in SolidWorks how to drag the project in SolidWorks from Altium. It will take a bit of time to open, but it should be quick. Yeah, it's loading Altium co-designer since the plugin is installed, so it will allow me to integrate my harness in here. So this is the Altium co-designer plugin. I'll go there. I'm already logged in, so I'll set my location for my harness assembly to appear in my local disk. Project webinar, Altium webinar. Here I'll just populate my harness, or I'll name it as harness ASYM assembly. Double click, select folder. This is now my harness folder location. Once this is done, I'll go and pull from my Altium library. Double click this. It will show me my changes, and whatever changes, it will appear here. Since this is a first push, I'll press OK. SolidWorks will start creating the project documentation. I'll just select my folder where I saved everything. All the connectors and the harness layout will appear here. So this is the advantage of having a plugin. And yeah, and then you can start routing or start dragging your connectors in any direction and align it with the mechanical assembly. So I'm just waiting for the assembly to be made in SolidWorks. Yeah, it has started creating our connectors 3D models. And this is done automatically, and because I have the plugin, so it's creating each and everything by itself. Yeah, this is the SolidWorks Part 3 Manager. And I'll have my harness assembly as well here. Yeah, so there's my harness assembly, which is the layout I created here. Something like this. I mean, it will not be the exact same shape, but something like this will come in SolidWorks. So everything is done automatically. I'm not touching my computer. SolidWorks is now working, and Altium is just pushing each and everything I created in Altium. All the properties of the cables, wires, connector names, each and everything will appear here. So once it's done, it will tell me to edit my harness and route it towards my mechanical assembly. Yep, this is successfully imported. Close. And now I'll be able to drag or move anything I want in SolidWorks. Since it was created something like this, that's how it looks like, my layout, and I'm also able to edit the route. If anything has been created extra, I can delete it, or I can see the properties from my electrical tab here. So the bend radius here is very small. That's why it's giving me an error. But that's all at the moment from my side. This will now be the routing routing section and how to route your cable and harnesses in a mechanical assembly. You can always set up your directions for your CP points in this mechanical assembly as well, and these are your branches and so on. Coverings can also be applied, which means you can cover your harness by a tape. Place harness covering. So if I start from here, a cover will start appearing, and it will cover this bundle, and I'll keep creating more coverings. So again, I'll fix this covering by naming it, giving its designators and stuff. So this in my layout drawing will appear or as well, so the manufacturer can see it. I'll just import changes from my layout. Here we go. The cover is now appearing here, and the manufacturer can see it, that it's covered, and that's how it works. So that's from my side, but I have already routed this harness, which definitely requires more time to show to you guys, but I have a picture what has already been done. It's something like this. If you can see that the branches are going into their respective positions, and the color of the bundle harness is red, you can give it whatever color is suitable for you or whatever is required. All the BMS connectors and each and everything is here. So that's all from my side at the moment. And if you have any questions, surely you can ask. And yeah, thank you very much. I'm up for it. Thank you.
Thank you so much, Serya. It was absolutely worth it to go this extra mile to see that interaction with SolidWorks. If you have any questions, guys, ladies and gentlemen, just post that in the chat and we will discuss it. I think we have one question related to that interaction with SolidWorks or with MCAD. We have received that previously, and the question is, how do you typically handle the ECAD MCAD collaboration in Altium when mechanical constraints like bend radius, routing paths, or enclosure limitations affect the harness design?
Yeah. This is a very good question. So the main concept or the significance of Altium and any CAD software collaboration is based on this MCAD ECAD collaboration. So once we bring in our harness into the MCAD, we can definitely route our harness towards our mating half of the connectors, which defines, from there you can define your bend radius of your bundle, which needs some calculations. And also, if the bend radius is not correct in SolidWorks or in your CAD, it will give you an error, and you have to fix that error for your route, and then you can move forward. That's how it works. And for enclosure limitations, definitely once you're able to see your enclosure, you will be designing your harness based on, or route based on that. So this is another thing which will save you a lot of money on wires, routing and stuff. Slack percentage is also another important thing, like how much slack you want in your harness, in your route. For coming out of each connector, the bundle has its own slack percentage. That's another important factor. Yeah, these are the things which should be taken care of. Yeah, thank you.
All right, thank you. And another one would be, what are the best practices for keeping harness design synchronized with PCB or multi-board changes, especially late in the design cycle?
Yeah. So since Altium was basically designed for PCBs, PCB designing was the main thing which Altium used to do, but they found out that there's scope for harnesses as well, where the connectors on the PCB, once they are integrated or connected, that PCB can also be imported to CAD, and then from there on you can create your harness from that PCB as well by defining the connectors and also your routes on the PCB. So this could be done. The synchronization is also the same in as the same as Altium Harness. So the PCB can also be imported in a 3D model, and then you can make your harnesses based upon that. Yep.
Right.
Yeah, and also Altium provides you the capability to control your revisions directly. You don't need to do the revisions again and again. It does it automatically for you, so you don't need to take care of that. Yeah.
Oh, that's useful. Yeah. Awesome.
You're welcome.
Thanks a lot. Just checking the chat for some other questions. I think we have covered the questions so far, and we will be distributing also some slides after the webinar beside the recording. So you will have there all the slides and all the, let's say, screenshots from today's session, and I think even a couple of more slides that we have a lack of time to cover or to demonstrate. Also, after the webinar, you can always reach out to Sherya if you have any questions. He is also our platform member, so you can give him a message, and he will be, I think, willing to help you with your project.
Sure.
We have also prepared a discount code, WiredWhite 10, for every purchase on the platform. Since we have also some online courses there, we have also an option for a paid tutoring consultancy. If you are facing some issues with your model or some technical questions may appear after the webinar, you're always welcome to schedule a call with Sherya and discuss any technical topic that you have in the private tutoring session with him. Yeah, so that would be it. As I said, we will distribute also the slides, the material after the webinar for those who have submitted and who have filled out the registration form. You will receive the email after the webinar. And I would like to thank you, Sharia, for giving a speech today, for introducing this interesting topic, and also giving some extra insights into that, let's say, cooperation with SolidWorks using some add-ons and apps. That was very useful.
Yeah.
Any final words from your side to our attendees?
Yeah, sure. So since we are, I'm working in the industry, in the automotive industry, and it's the journey since I have joined the automotive industry has been pleasant. I have worked on different areas in the vehicle, from ECU components to the cameras developments, and also to different kind of vehicles, industrial vehicles. I have worked on these as well. I'm based in UK now, and I'm working as well. I have taken up some mil spec harnesses as well. I'm making them for one of my client in US. So harnessing is definitely something very emerging in the future, which is connected once it's connected with the MCAD, and also designing or making your concepts clear about each and everything about the harnesses, like wires, cables, connectors, terminals, crimps. These are all terminologies, and they are very important to be known, since we are moving towards the controllers in the vehicles as well. A lot of ECUs are being used now in the software-defined vehicles. So it's very important for us to learn and keep sharing. And I'm always available to take up on projects. And if someone wants to have some tutoring on Altium and SolidWorks routing and SolidWorks electrical as well, I'm available. And you can just send me a DM, and I'll be, we can just talk over there and decide when I can do some tutoring for you guys, and then we can take things from there forward on. Yeah, I'm always welcoming and taking up challenges ahead in my life. Thank you.
Absolutely. Yeah. Thanks a lot, Sharia. And thanks for the webinar. And thanks to all the attendees having some time today for joining. I hope you enjoyed it as much as I did. And see you in the next one very soon.
All right.
Bye-bye, guys.
See you. Ta-da. Bye-bye. Take care.
Take care.